In this video, we will be finding the eigenvalues and eigenvectors of a 2 by 2 matrix. So let's say we want to find the eigenvalues of matrix A. To do that, we have to find the determinant of the matrix A, and we have to subtract this diagonal by lambda, and we set this equal to 0. And now let's just solve for this. So the determinant of this matrix is 4 minus lambda times 3 minus lambda minus 1 times 2 equal to 0. And now let's just solve for lambda. So let's expand everything. So we have 12 minus 4 lambda minus 3 lambda plus lambda squared minus 2 equal to 0, which simplifies to lambda squared minus 7 lambda plus 10 equal to 0, which factors to lambda minus 2 times lambda minus 5 equal to 0. And this means lambda is equal to 2 and 5. So lambda is representing our eigenvalues. So our eigenvalues for matrix A are 2 and 5. After we found our eigenvalues, we could find our eigenvectors. So let's find our eigenvectors for the eigenvalue 2. So remember this matrix, 4 minus lambda, 1, 2, and 3 minus lambda. So we want to substitute lambda for 2. So this will give us 4 minus 2, 1, 2, and 3 minus 2, which gives the matrix 2, 1, 2, 1. And after we got this matrix, we can move on to the next step, where we multiply this matrix by x and y, and set this equal to 0, 0. And now we can solve for this system of equation. So this will give us this system, where our first equation is 2x plus y equal to 0, and our second equation is also 2x plus y equal to 0. And since these equations are the same, we know that 2x is equal to minus y. And now let's find our first eigenvector. So let's just choose x equal to 1. And now we can isolate for y. So this means we have y equals negative 2x. So when x is equal to 1, y is equal to negative 2. So our first eigenvector, let's just write it like this. The first eigenvector is equal to 1 and negative 2 when our first eigenvalue is equal to 2. For our next eigenvalue, so we have lambda equals 5. Let's find our eigenvector for this. So same procedure. So the matrix 4 minus lambda, 1, 2, and 3 minus lambda, which gives us, so now let's substitute lambda equal to 5. So we have 4 minus 5, 1, 2, and 3 minus 5. And this gives us the matrix negative 1, 1, 2, and negative 2. And now let's multiply this matrix with x, y equal to 0, 0. And this gives a system where our first equation is negative x plus y equal to 0. And our second equation is 2x minus 2y equals 0. And if we subtract the second equation by negative 2, this will give us, for our first equation, it will be negative x plus y equals 0. And our second equation will also be negative x plus y equal 0. So we can see that these two equations are also the same. so we can find our eigenvector. So let's choose x equal to 1, and we can see here that minus x is equal to minus y, which means x is equal to y, so that means y is also equal to 1. So when lambda is equal to 5, or when our eigenvalue is equal to 5, our eigenvector can be 1 and 1. So now let's give a quick recap. When our first eigenvalue, let's call that lambda 1, when our first eigenvalue is equal to 2, then our eigenvector, let's call that v1, is equal to 1 and minus 2. And when our second eigenvalue, let's call that lambda 2, when that is equal to 5, our eigenvector, let's call that v2, is equal to 1, 1. If you found this video helpful, please leave a like and subscribe to the channel. And thank you very much for watching.